In this vlog, let's take a look back at an environmental crisis that took place pretty much worldwide and involves science prior to the global warming crisis. We have to look at something called ozone and its relatives. Ozone is related to oxygen molecules. An oxygen molecule is two atoms of oxygen double bonded to each other, as shown in the top of this graphic. When an additional oxygen atom is bonded to that molecule, then the molecule becomes something called ozone. Ozone is slightly charged with a positive charge near the center oxygen atom, and then a more negative charge near the oxygen atom that's on the wing. Also, oxygen can exist as a single atom, as shown at the bottom of the graphic. There are two cycles of chemical reactions in the upper atmosphere that ensure these entities are always present. Here's a picture that shows the three categories of ultraviolet light that come from the sun. On the right, we can see the wavelengths that they are described by, and we can see in the photograph that the worst ones, labeled C, are blocked by the upper atmosphere. The middle ones are vastly reduced, and the weakest ones do make it through to the surface of the Earth pretty much the same as they arrive. The numbers on the left are the wavelengths at which the ultraviolet photons enter into the cycles that maintain the protective ozone layer over the Earth. The way they enter into the cycle is they break off the oxygen wing from the ozone molecule, and then the photon's energy has been utilized to do that, and the photon ceases to exist. In 1985, the British Antarctic Survey discovered that there was a hole in the ozone layer over the South Pole. Here's a view of the ozone hole and a view of the Earth, the black being the absence of ozone. Scientists identified the causes of the ozone hole by a combination of observational data, mathematical modeling, and experimental testing. They used instruments like the Dobson ozone spectrophotometer to measure UV light reaching Earth, accurately measuring ozone levels. The thinning turned out to be due to the destruction of ozone molecules by chlorine and bromine atoms from chlorofluorocarbons, which are CFCs. These CFC chemicals were widely used in refrigeration, aerosols, and other industrial applications. It turned out that the chlorine and also the bromine from these chemicals was facilitating thousands of conversions of ozone into oxygen. While oxygen is not a bad substance, it was removing the ozone, and when the ozone was removed, the dangerous ultraviolet photons made it past the upper atmosphere. There wasn't any ozone there to absorb the energy of the photons and remove them from the stream of photons coming down from the upper atmosphere towards the Earth. Jumping around the political aspects for a period of time, let's look at how the technologists solved the issue. They invented refrigerants that did not have chlorine or bromine in them. Specifically on this diagram here, we see HFC-134A, or as it's sometimes referred to, R134A, and it did not have chlorine or bromine, which was important. But how this ties into global warming is interesting. They realized that this chemical had a high global warming potential, so they had to stop using it and come up with another generation of refrigerants. Here we have a view of one of those new generation of refrigerants, R630A. It's completely carbon and hydrogen. It both avoids the chlorine and bromine atoms and has a low global warming potential. So that's all good. The one disadvantage is that it's relatively flammable, and anybody who works with this coolant in a refrigeration unit has to be certified and utilize non-sparking tools. Now let's take a look at the organizational and political history of this ozone issue. The first paper demonstrating the losses in ozone and laying out the fact that there's an ozone hole was in 1985. In 1986, satellites were used to show that the hole was quite large. And then in 1989, the Montreal Protocol internationally supported the ban of 100 chemicals to fix the ozone issue. In 1995, the first treaty was signed. In 2005, the second international treaty was signed. And in 2019, the third international treaty was signed that protected future generations. Because of this quick action, the ozone levels in the stratosphere are returning to normal. It will take decades. Might not be completed until 2050 or 2060, but things are already a lot better. Also, if we look at the history, it's interesting that corporations and national economies survived without issues. Let's look at this ozone issue, this major environmental issue of worldwide significance, and then compare and contrast it with global warming, which similarly has worldwide effects. One thing that's amazing to me is that the ozone issue went from virtually unknown to relatively strong action in 4 years. Also, the international cooperation continued and continues to this day. The ozone levels are recovering. The corporations and economies all survived the relatively strong bans on making certain chemicals and distributing them. And then overall, all of the actions were based on science instead of what's happening in the US, where we're taking steps backwards on global warming and ignoring science. In terms of the issues of ozone, science was and is relied upon.